Okay, our objective today is to graph and solve systems of linear equations. So we're going to go back to graphing today, as well as the next lesson. Those are the last 2 lessons of this chapter. But I'd like to start with your warm-up to make sure you're okay with writing equations without seeing a graph. So let's start with the first warm-up that you have, and this is the one that was in your homework packet. I'm just going to go around the room. I want you to tell me what you got, and then, yes, of course, any questions we'll come back to. Grace, can you tell us what you got for number 1? Great job. Skylar, number 2. Good job. Number 3, Josh. Good job. One little thing, you can simplify negative 8 over 28. 4 goes into both of them. You don't have to, but if you did simplify, it should be y equals negative 2/7 x plus 24. But Josh, I would not mark that wrong. Okay, number 4, Amberly. Okay, great job. Same thing with you that Josh said. The 18 over 21 can be reduced to 6 over 7. 3 goes into both of them, but I would not mark that wrong because you're fine. Your slope is still right. It's just easier if you guys and girls simplify them completely, especially when you go to graph them. But again, you do not have to. Drew, you want to do the next one? Okay, go ahead. Negative. Okay, good. Good job. And then y equals? Great job. Some of these were tough because the fractions, I got these problems from a practice C worksheet. We did these last year as well. So some of these I know are a little bit tough because of the numbers. All right, number 6, Shane. Okay, Greta, number 6. Good job. And let me move this last one down here. Okay, number 7, Steve. Close. You just need to fix the slope. Neil, what'd you get for your slope? Negative 3/8, but yes. Good job. Number 7 was definitely, I think, probably the most challenging on that page because they gave you a fraction, or if you change it to a decimal, as part of your ordered pair to use to find slope. So let's talk about this one first. Any questions on any of this, Skylar? Okay, if you take your calculator and do 1.5 divided by 4 and hit math, enter, enter, it changes it to this for you. So in the future, try to keep your slope so it's not a decimal over a whole number. Okay? You remember how to do that, right? Okay. Neil? That's fine. You can do that. Camille. Let me make this bigger for you. Go ahead. Yeah, the answer for number 6 is y equals negative 6/7 x plus 4. Do you want me to explain part of it, or are you okay? Sure? Okay. Anyone else? Any questions on this warm-up? Steve? Number 7? Okay. Number 7, let me start this off, and maybe some of you guys didn't realize this. They gave you 2 ordered pairs on number 7. They gave you the origin, which is 0, 0, and they gave you 4, negative 3 over 2. So you need to use 0, 0, and 4, negative 3 over 2 to find slope. So negative 3 over 2 minus 0 is just negative 3 over 2. That's your y2 minus y1, and then 4 minus 0 is just 4. This is what Skylar had said. So when you find your slope, if you take your calculator and do negative 1.5 divided by 4 and hit math, enter, enter, Steve, it gives you negative 3/8. And they already give you the y-intercept, which is 0, negative 7. So that part's already there for you. Anyone else? All right, let's go to the next warm-up. Alexis, we're going to start with you on number 1. What is your b and what is your equation? B is not 1, but your slope is right. Nathan S? Good job. And I should be writing these as an ordered pair, sorry. Okay, number 2, Jackie. Good job. And some of these are tricky, so make sure you're checking. Mike, number 3. Did you do any of them? Ray, number 3. You can get to any of them? Okay, Ben, number 3. Okay. Evan, number 4. What did you say? Evan, sorry. You didn't look at the board? Oh, you didn't get to. All right, Joseph, number 4. Nope. Kevin? Neil? You told me you were done. Okay, good. Okay, number 5, we have B should be 3. And the equation is y equals 2x plus 3. Number 6, B is 5. We have y equals 5 on this one because your slope is 0. So you only have y equals a number. Nathan S., go ahead. Oh, sorry. All right, so those of you that did not do this, you need to try this warm-up. These are the harder ones from yesterday where you're not given the y-intercept. So it's up to you to make sure you go back and try these on your own before your test next week. You will definitely see problems like this on your test. Any questions on any of those, 1 through 6? Nathan, am you okay now? Okay, why aren't you asking? Okay, pick one. I'll do one. Okay, all right, let me go over number 1. Okay, number 1, you are given that the slope is -2 and the line goes through 4, 5. So those of you that got confused on these, make sure you listen. First step is find slope, but we're already given slope. Second step is plug the slope into the slope-intercept form equation. Okay, now what? Who remembers from yesterday? How do you find B? Shane? Awesome. Plug in your x, plug in your y, find B. So we have 5 equals -2 times 4 plus B. We have 5 equals -8 plus B. After you add 8 to both sides, we know that B is 13. So your y-intercept is 0, 13, or 13. When you put that back into your equation, that's how you get to y equals -2x plus 13. Nathan M, does that help a little bit? Sure. Kevin? Nope. Should be -3. Can we do it real quick? All right. So number 2, we have the slope is 2. And it goes through the point 5, 7. Okay, so we're going to plug in 5, 7. So we have 7 equals 2 times 5 plus B. 7 equals 10 plus B. Kevin, how do you get 10 to the other side? Yeah, so 7 minus 10 is -3, not 17. Got it? Gio. Number 6, okay. Before I go to 6, is everyone okay on 1 and 2? Okay, number 6, you know right off the bat that the slope is 0. So we have y equals 0x plus b. And you know it goes through 3, 5. So I'm going to start there. Slope is 0, you know it goes through this point. Plug in your x and your y. 0 times anything is 0. So you know your b is 5. If we go back and plug that into our original equation, we have y equals 0x plus 5, but 0 times anything is 0. So this is one of those lines like the people mover at the airport. It goes like this. There's not a rate of change. There's not a slope. So it's just y equals a number. Sure? Okay. Anyone else? Nathan S? the equation for number 7? I don't have the answer, but let me do it real quick. Nathan asked, what did you get for B? You got it. Yep. You're good. Okay, anyone else? Okay, let's go over homework quickly, and then we're going to move on to our lesson. All right, Steve, we're going to start with you here. Number 1 on the homework. What did you get? Good job. Neil, number 2. Good. Abigail, number 3. Good job. Greta, number 4. Good job. Gio, number 5. Good job. Number 6, Drew. Nope, you're close. Grace, what did you get for number 6? Oh, go ahead, Drew. Sorry, Grace. Good. So negative 1x or negative x minus 1. Grace, number 7, please. Good job. Number 8, Joseph. Close. Michelle, what'd you get for 8? Good job. Make sure you guys and girls have negative 1/3 on that one. Peyton, number 9. Oh, yeah. I keep forgetting that. Sorry. Amberly, number 9. Good. Negative 4x plus 5 or negative 4/1. Either way is fine. Shane, number 10. Good job. Y equals negative 2. That's another one of those problems like the warm-up where the slope is 0. You just get y equals a number. Mike, 11. Negative what? Your slope's off. Jackie, what'd you get for 11? Good job. Camille, number 12. Good job. 13, Ray. Close. 10? Good job. Plus 3. Your y-intercept in the table they gave you, 0, 3. So you just messed up on the B part, Ray. Okay, so there's the homework. Questions, anything that you can't read, any repeats? All of these problems are fair game for your Chapter 8 test. Just make sure you're keeping up with everything. Abigail? Okay. Number 13, the easiest way to do this is to pick 2 points to find slope. So what 2 points did you pick? Do you remember? Okay, and that's what I did too. So if you did the first 2, we have x1, y1. So here's our first ordered pair. Second ordered pair, just make sure I'm doing this the way you did. Negative 2, 4, so x2, y2. Okay, using your slope formula, we have y2 minus y1 over x2 minus x1. Did you remember those 2 negatives back to back? Okay. So 4 minus 5 is negative 1. And then negative 2 minus negative 4 is really negative 2 plus 4, which is 2. Okay. So you just forgot about the negative there. Okay, if you look at the table, do you see how the x is 0? When x is 0, whatever the y is, that's okay. That's the y-intercept. Okay? You okay? Anyone else on the homework? Positive. Give me a thumbs up, thumbs up, thumbs down on writing equations, which is what we did yesterday and what Ms. Wingrove did with you with the picture graphs. Shane, thumbs up, thumbs up, thumbs down. Neil, thumbs up, thumbs up, thumbs down. Okay, thank you. All right, let's open up your notes, please, to 8.8. We are skipping function notation. The reason I'm skipping that is it does not really go along well with this chapter, at least as well as I would like it to. and that's something that we'll spend a lot of time on next year. I'd rather have time this year to get through the geometry chapter, which is chapter 10. So we're skipping 8.7. We're going to page 27 in your notes, which is lesson 8.8. So you should have a calculator on your desk. Does everyone have a calculator? Okay, please make sure when you come in for the day you look at the board. Okay, so just an overview of this lesson. This whole lesson is about graphing systems of equations. All we're doing now is we're going to be graphing two equations on a graph. So we could end up with one solution, no solution, or infinitely many solutions. Does anyone have any idea what the lines might look like if we have one solution? So if we graph two lines, what do you think they're going to look like if we have one solution? Gio? If they're going to be the same line, are they just going to have one solution? So if I were to graph the same, ooh, there goes the chalk. If I were to graph, Gio, the same line, so here's one line. Let's say we have a line that's identical to that. And I were to graph it again. So there's our two lines. That does not just have one solution. How many solutions does that have? Infinite. So Gio gave us, not the one I was asking for, but that's okay because we're getting to this as well. If you're graphing the same line, there's going to be infinite solutions. And here's an example of when you'll have infinite solutions. You got it? Okay, so what would the graphs look like if we had one solution? Grace? It would be a point, is that what you're saying? Okay, so what, show me with your hands or just explain to me, what would the lines look like? Okay, so like if I had one line here, Grace, and one line going here, you mean like that? Okay, that's what it should look like. You're right about the point because they're going to cross and they're going to connect at one ordered pair. We're going to do a lot of that today. So that's with one solution. What if there's no solution? What do you think the graphs would look like if there's no solution? Mike? They won't intersect. So what are they going to look like? Awesome. They're going to be parallel lines. If there's no solution, they're just going to keep going. They're going to be parallel. They're going to have the same slope. They are never going to touch. So that's basically today's lesson. The first graph over there is 0 solutions. The second one is 1. The third one is going to be infinite. Does that make sense, Gio? No. No. Nope. And we'll get to that discussion next year. Yeah. Good question, though. Glad you're thinking. And good job saying the word parabola. Very good. Yeah, I like how Ray says it. All right. So let's do, it says it's a warm-up, but this is really an intro to the chapter. Let's do this together. So let's go to number 2. Number 2 on the warm-up that it says here, it says try your method on one of these. So I want you to look here. Don't worry about the first one. They give us two equations here. We need to determine whether this is a solution of both of these equations or not. This is something in Algebra 1 that's called linear combinations. So we need to determine, is this ordered pair a linear combination of these two equations? How would we do that? How would we determine if it's a solution or not? Amberly? Awesome. So let's do that. So if we plug in -3 for x, let's do the first equation. We have -3 plus y, which is 1, which is equal to -2. Is -3 plus 1 -2? Yep. So let's put a check mark. That's true. That's a solution. So let's look at the second one. We have -3 for x, 1 for y, equals 2. So is -3 plus 5 equal to 2? Yep. So yes, and the terminology you should use is this is a linear combination of both linear functions, which means when you graph them, it's going to be a solution of both equations. It's where they intersect. Okay, let's try the second one. We have x is 5, y is 2. So we have 2 times 5 minus 3 times 2 equals 4. So we end up with 10 minus 6. Is 10 minus 6 4? Yep. I hope you're going to say yes, right? We're just practicing order of operations. So yes, that first one is true. Let's look at the second one. We have 2 times 5 plus 8 times 2 equals 11. Is 10 plus 16 equal to 11? No. I hope you say no. Put an X. That means, bless you, this is not, 5 comma 2 is not a linear combination of that system of equations, which means both of these equations. Questions on that? All right, let's start graphing. Look at example 1. In the graph paper on your desk, we're going to use in a little bit, and you're going to use for part of your homework tonight. All right, so letter A for example 1. It says solve each system by graphing. I want to do this by hand, and then I'd like to show you on your calculator. If not this one, later on in the notes, I'm going to show you on your calculator how to do this. Okay, I'm going to do the first one in blue and the second one in a different color. You're fine to use your writing utensil. So I want you guys to tell me, Evan, when we graph the first one, y equals x plus 1, where do we start on the graph? Good. Start at your y-intercept, which is 0, 1. Michelle, our slope is in front of x, so what do we do next to get to the next point? Good. Up 1 over 1, up 1 over 1. How do we get the opposite point, just as a review, Camille? Good. Down 1 to the left 1, down 1 to the left 1. Connect your points. So there's our first equation. Now, if I wanted you to be really, really neat, I should have probably given you rollers today, but just be careful when you're graphing. I'll definitely give them to you on the test because we need to find where these cross. So just make sure you're trying to be neat. Okay, the second one, of course, this is going to be a pain because we have to start at 0, negative half. So as careful as you can and as close to that as you can. Go ahead and plot a point at 0, negative half. And then our slope is going to be negative 1 over 2. So we're going down 1 to the right 2. Down 1, bless you, to the right 2. Again, be careful because this is going to be ugly. To get the opposite point, up 1 to the left 2. Up 1 to the left 2. Okay, connect your points. And mine's actually not too bad. Usually I'm messy with these. Where, or in other words, what is the solution of this system of equations? What is the solution? Greta? Close? 0, negative 1 is right here. Good job. The solution to them is negative 1, 0. It is right here. Now, I know mine's not perfect, and I'm sure yours is hard to tell as well. I'm going to show you how to check it on your calculator, but if you did not have a calculator, how could you check this? How could you check this? Gio? Nope, nope. How could you check it if you didn't have a calculator and you don't have a roller? Grace? Awesome. You could plug this ordered pair into both of those equations, and you'll find it's true for both. For example, on the first one, when you plug negative 1 in for x, negative 1 plus 1 is 0. If you plug it in for the second one, negative 1 times negative 1/2 is 1/2. 1/2 minus 1/2 is 0. So it's true for both. You know it's right. Nathan S. Yes. Yes. So I'm getting there. So I want you to write underneath it, thank you, Nathan S., that this one has one solution, because this is part of your homework tonight. It only crosses at one spot. So there is one solution, or there's one linear combination that works for both of those systems. Okay, let's go to your calculator for a minute, then we're going to do some more examples. Oh, man. Okay, on your calculator, I want you to go to the y equals, and I want you to clear your home screen. And if there's anything in the y equals, clear what's in there, please. Y equals is the very top left. Nathan, you're just going to have to watch or see if there's an extra calculator over there, because your calculator doesn't do this. So the very top where it says y equals, is everyone watching? Is everyone on this screen? Give me a head nod. Yes. Okay, I want everyone to type in, we're going to type in the first equation. X is to the right of alpha. So everyone type, my finger's right on it. X is to the right of alpha. Type X. Mike, what's wrong? Okay, I thought you were confused. Okay, X and then plus 1. So plus 1. So there's our first equation. Use the down arrow to go to y2. So hit the down arrow. We need to type in the second equation. I need you to put parentheses. Oh, just one parenthesis. So put a parenthesis. Parenthesis is right below something called cosine. Okay, type in negative. The negative's at the bottom. 1 divided by 2. End parenthesis. X. And then minus 1/2. So I'm going to put it in parentheses again. Remember, the calculator is not always the smartest thing. Okay, so make sure you have what I have. Drew, you okay? Okay. Okay, is everyone okay? Okay, I need everyone to hit graph. So hit graph. Isn't that awesome? I need like that. Hold on one second, Gio. Once you hit graph, if yours does not, does anyone's screen, like is anyone's screen zoomed in or zoomed out? All right, raise your hand for a minute. Who else? It's probably because you didn't type it in right. Did you use this X? Yeah. Hold on, don't, you forgot. Oh, no, you do have it. Okay. I want you to do it again. Drew, the equation is in your notes. The two equations. Try that. Okay, who else has their hand up? Don't worry about that yet. I'll fix yours later. Okay. Is yours okay?
Yeah, but Nathan added a couple ones.
Okay, well, I didn't want you to add a couple. Okay, who else? What happened to yours? It just is an error?
No, it like won't show up in the graph.
There you go. Okay, I want you to do yours again. At some point, I'll show you guys what I'm doing to fix this, but not today because we don't have time. Okay, I want you to do it again. Do it again while I'm checking everyone's. No, that's probably why. Okay, I want you to try yours again. All right, so everyone that's retrying it, I want you to watch me for a second. Here's how to check your answer on the calculator. Those of you that have it up, do this. Everyone else watch. I want you to hit second trace. Second trace. Say that one more time. Hit second trace. Good job, Mike. Number 5 says intersect. Press number 5. Hit enter 3 times. You ready? 1, 2, 3. Some of you may have to hit it 4. So look how awesome this is. It says intersection, -1, 0. You can use it to check, but I need to see your work. So, I'm getting to that. Hold on. Any questions on how to check on the calculator? Skylar. Maybe you typed your equation in wrong. Go back to y equals. And I'm going to keep going, Skylar, but I'll check it again for you at the end of class. All right, let's look at your notes. Let's go to number 2. If there's more calculator problems, I'll come around in a little bit. It is awesome, I know. All right, Neil, I'll get to it in a little bit, okay? All right, I want everyone to look at letter B. Shh, 6th grade, letter B. Okay, letter B. What is different about this one than letter A? Camille. Good. The equations are not in function notation form. In other words, they're not in y equals form. So let's get them into y equals form. The first one, we need to subtract 1 on both sides. So we have negative x minus 1 equals negative 3y. And then to get rid of the negative 3, we are going to divide everything by negative 3. So who can tell us the first one is what in y equals form? Grace. Good job. Okay, let's graph this one. I know this is kind of ugly, but we can graph it. Start at 0, 1/3. So to 0.3 repeating. And then your slope is 1/3, so you need to go up 1 over 3. Up 1 over 3. To get the opposite point, then you should be with us, not on the calculator. Calculator down. Down 1 to the left 3. So connect them as neatly as you can. Okay, let's put the second one into y equals form. All we need to do on the second one is divide everything by 3. So we have y equals 1/3 x minus 1. Before I graph this, what's going to happen? Abigail? Good. How do you know that? Good job. They had the same slope, so you know they are definitely going to be parallel lines. So starting at negative 1, we're going to go up 1 to the right 3, up 1 to the right 3. To get the opposite point, down 1 to the left 3. Oh, that's a little crooked, but you get the point. Connect them. They should be exactly straight and exactly parallel. So these are parallel lines. How many solutions does this system of equations have? David? Good. 0 solutions because the lines are parallel. They have the same slope. So your answer would be to show your graph and to write down that there's 0 solutions. Neil? Yeah, you can put down no solution. Yep. Questions on that one? Okay, I want everyone to jump to letter D. So go ahead to letter D. Okay, I'm going to get to the calculator again in a second. So let's go to letter D. Okay, Steve. Okay, I'll get to that in a little bit. Go to letter D first. Don't worry about that right now. Okay, letter D. So this is pretty easy. We have 2 equations, x equals 4 and y equals negative 2. So how do we graph x equals 4? Abigail? Okay, and is it like this or is it like this? This way. Remember, x equals a number. You can't walk up a wall. Your slope is undefined. That's okay. That's okay. So x equals a number always goes this way. As Abigail said, it's going to go through the 4 on the x-axis. So there's our first line, x equals 4. Y equals negative 2, Mike. What does that equation look like? Good job. Horizontal line going through negative 2. Your slope is 0 in this one. Just by looking at this graph, how many solutions does this have, or does the system have? Shane? Good. It's going to have 1 solution. Who can tell us what this solution is? Ray? Good job. Drew? That one we're not going to put in the calculator. We're not going to do that one. Miss Wingrove, do you know how to change the y equals to x equals? Okay, neither do I. I haven't figured out a way to do that. There might be a way, but no. That's something different. That's for finding an x value. But anyways, this one is easy enough that you do not need to check this on your calculator. Okay? Any questions on that one? Yeah, it is pretty easy. Hold on. Nathan S. Yeah. Yeah, those are for different functions. Don't worry about that yet. Tomorrow I'm going to do more at the calculator, Nathan S., and I'll show you some more of that. Correct. All right, I want to do two more things, and then we're going to be done. Letter E is not in your notes, so I want you to go to this little graph paper that I had on your desk. I want you to put a letter E at the top, and I want you to use this graph paper for this problem, and then you're also going to use it for one problem on the homework. So put a letter E at the top. Okay, and I want you guys and girls to put the second one into function form. And then after you have it in function form, just sit tight for a little bit so that we can talk about that. And if you are having calculator problems, I'll either help you in a couple minutes or tomorrow morning. So put that second one into function form or slope-intercept form. And then you're going to use that graph paper to graph it. Okay, letter E, what should function form be for the second equation? Greta? Okay, so without graphing, who can tell us what's going to happen? Evan, what's going to happen? Awesome. It's the same line, so it's going to have a ton of solutions, which is going to be infinite solutions. Let's graph it anyways on your little graph just for practice. So start at 0, 3. Your slope is 2, so up 2 to the right 1, up 2 to the right 1. Opposite point, down 2 to the left 1, down 2 to the left 1. Connect it. If we go to graph the other one, it's going to be the exact same line. So I'll do it anyways, but they're exactly on top of each other. Gio, what are you doing? Okay. So this one does not just have one solution, it has infinite solutions. You may also write down on your paper many solutions. You should remember from the beginning of the year, that's the sign for infinity. You guys remember that, right? Okay, so you can either use the sign for infinity, or you can just put, this system has many solutions. It's the same line. Nathan S. Yes. Good job, Nathan S. And again, there's a whole chapter, if I have you guys next year, we're spending an entire chapter on parabolas. They're fun. Gio. Well, don't worry about that. Don't worry about that right now. Next year, that's a next year concept. Before I wrap up here, I did want to do that closing word problem with you guys. We'll do it tomorrow morning instead. I need more than a couple minutes to do that with you. Your homework, you will have a word problem. So I need everyone to open up your homework packet to 8.8, please. No, these ones I want you to do without the calculators. So no, you're going to leave the calculators here today. We're going to spend some more time on them tomorrow. I at least wanted to show you one today with the calculator. We'll do more of that tomorrow. It is neat. It's good to know to check your answer. However, the first thing I need you to make sure you can do is do this without a calculator, and then you'll have that calculator as a tool to check. I don't want you to always depend on that because, as we know, sometimes technology does not work well. Okay, practice 8.8. You're going to do all of it. There's only 15 questions. Hold on. I need everyone to take a look at it. Let's see, 1, 2, and 3 is what we did the very first part of the notes. It's a linear combination, so is it a solution of both equations or not? You're going to put yes or no. 4 through 12, make sure you listen carefully. You need to do a couple things here. You need to make sure the equations are in y equals form, or in other words, slope-intercept notation. You need to graph them both, and then you need to tell me, does it have one solution, 0 solutions, or infinite solutions? If it has one solution, you need to write down what that solution is. Is everyone clear on that? So the exact same thing we did in the notes today. 13, 14, and 15 are application problems, which means they're just word problems. They're very straightforward. Use the graph paper for number 15. So that little graph paper that you had, use that for number 15. Bless you. All right, is everyone okay? Thumbs up, thumbs down, thumbs down on today's lesson. And we're going to do more with the calculator tomorrow. All right, I think girls are first today.
Boys.
Yep, girls are first today. Go ahead and get packed up. Calculators all back, please. I want you to do the homework without it. Well, that's, Neil, that's different. Where is the recorder?